parameters of that. So A was the amplitude, and then K was wave number, then frequency, and then time period, everything we talked about in the last class, right? Okay, so then, and we also know that what was the transverse wave and what was the longitude. Transverse wave, when the wave propagates in crest and trough, that is the transverse wave, and then we have this longitudinal wave, right? So in a wave propagation, what was this quantity, right? What was this quantity? We have a wave which is propagating like this. So what is this quantity? The distance between two crests and distance between two troughs. What is that? So that is the wavelength, right? This is the wavelength. In this part, we have wavelength, which is so this is the wavelength of the particle, which is the traveling. So this is the wavelength lambda. This is the wavelength of the transverse wave. Okay, so now let us right. Now let us move on and let us understand about velocity and velocity of the wave. Right. So now we will talk about the velocity of traveling wave, and we will also talk about the velocity of the particles. Right. So velocity of traveling wave, how can we calculate that? We know that there is this wave which is propagating, right? So this wave is propagating, and we know that the phase of the wave. So how do we write the displacement of the medium or the particle? This is A sine kx minus omega t plus phi naught, right? So wave, in the wave, this part, this phase remains the constant. So phase in a traveling wave remains constant. So this thing is a constant quantity, right? Because the wave is not accelerating. Wave is not accelerating. That is why this phase remains constant. So if this thing, let's say if this kx minus omega t plus phi, so x is the propagation of the wave, right? X is the propagation of the wave. Y is the displacement of the particle, right? So this is displacement of particle, and this x is propagation of waves, right? So this thing is, let's say, a constant c. So if we take the differentiation in both the sides, right? If we, let's say this is a constant, this is the phase, right? And let's say this is c. So if we take differentiation in both the sides, right? So what would be that with respect to t? With respect to t, we have to take. So this would be d by dt of whole thing kx minus omega t plus y naught, and this is constant differentiation. How much would be this quantity? What is the differentiation of a constant quantity? Yeah, so if we look back and remember differentiation, let's say 5. So differentiation of 5 with respect to time, that would be 0. Because change 5 is a constant number. If we want to calculate change in 5 with respect to time, right, so that will remain 5 always. So change in 5 would be 0. So differentiation of a constant is always 0, right? So this part is 0. This part would be how much? So k is constant, I can take it outside, so this is dx by dt. Similarly, omega is constant, I can take it outside, so this is dt by dt. And again, d phi naught by dt. Again, this is a constant, so this is again 0. Right, so what we will get? So we will get k dx by dt. That is minus omega. Dt by dt is 1, that is equal to 0. So we will get k dx by dt minus omega, that will go in the right side, that will be omega. So we will get dx by dt is velocity of the traveling wave, right? So this is v and this is omega. So velocity of traveling wave, we will get omega by k. So this v is velocity of traveling, right? So this is the velocity of the traveling wave that we get, and we can also write omega is 2 pi, right? And then k is 2 pi by lambda. So this 2 pi will cancel, lambda will go upstairs. So this velocity will also be can write as lambda. This relation you already, right? We have a frequency and then we have this wavelength that is related to the velocity of the wave. So this is one thing, right? And then we can also calculate the velocity of the particle, right? So what would be velocity of a particle? So we know that displacement of particle is what? So velocity of particle, that would be differentiation of the displacement. So y is displacement of particle. So from that we can always calculate displacement of particle. So Vp would be how much? D by dt of A sine kx minus omega t plus 5. Right. So we are taking the differentiation with respect, we can take it outside, and sine of this thing. What would be that? D by dt of sine kx minus omega t plus 5. Right. So we have to take the differentiation of this thing. So this would be how much? This would be a, and sine is cos kx minus omega t plus phi naught, right? And if we take the differentiation of this thing, right? So that is 0, but we will get this omega, right? This minus omega is there, so we'll get a minus omega. So this would be how much? This would be minus a omega and cos kx minus omega t plus phi. This is the velocity of the particle. similarly, we can calculate acceleration by dt. This would be how much? My voice is lagging. Why it is lagging? Yeah. So why is it lagging? Yes. So let me check the internet. The ping. Let me check the ping. Is it still tracking? Is it still?
Yes, sir, it is not clear. It is breaking.
Yeah, it is breaking. So why is it breaking? Because I have checked the internet and it is working fine, right? So why is it
Sir, I will
lagging?
join again. I think I have network problem.
Yeah, yeah. Please join again, right? Please join again. Yeah. So how is it now? Is it okay?
Yes, sir.
Yeah. So maybe yeah, your internet was. Yeah. So then we can calculate the acceleration of particle. So what would be the acceleration of particle? That would be differentiation of velocity, right? So this would be how much? This would be minus a omega, or if we write it, this would be d by dt of minus a omega and cos kx minus omega t plus pi. Right, so this will be how much? Minus a omega, we can take it outside. And then cos differentiation of cos theta, right? Cos kx minus omega t plus phi. So this is this, and then what do we get that, right? Okay, so then we have minus a omega, and then minus of sine kx minus omega t plus phi 1, right? And then multiplied by minus omega again. So this minus and this minus will cancel. So we will have minus a omega square and sine kx minus omega t plus 5. This would be the acceleration of the particle, right? And if we calculate the maximum acceleration, so sine that would be 90 would be 1, so that would be minus a omega square, right? Similarly, we calculate the maximum velocity. So VP max would be how much? So for VP max, this cos theta would be minimum, so that would be a. These are the things that we have to understand. Yeah, is it clear to you? Amna, is it clear?
Yes, sir.
Then please note down these parts, right? These are the velocities of different velocity of wave and velocity of particle. So who got disconnected? That, whenever you want me to scroll down, please tell me. Yeah, whenever you want me to scroll down, please that.
Done, sir.
Done. Okay, then
Done, sir.
Then uh, and AB max, yeah, we can write this as A omega square. The minimum would be how much? Minimum would be simply minus A omega square, and maximum would be just this. Similarly, VP minimum would be simply minus A, right? So because we know that that would be again a waveform, right? So whatever is maximum, right? Let's say this is maximum. So that same amount would be minimum, right? Only the negative sign would be there. Maximum or minimum are the same. Yeah, whenever you have noted that, whenever you have noted that.
Done, sir.
Yeah. Okay, so now let us do some questions, right? And then that would be very easy to question. And everything from that we can calculate. Because we have already done the oscillation part. This is somewhat or somewhat related to that, right? Let us do this question and then it would become very easy to why this is taking so much time. Yeah. I have this wave and they want you to calculate, right? So you have this wave, which is function of x and t, right? This is 0.005 sine 8tx minus 3t, right? So if we compare this with the general form, right? If we compare this with the general form, so general form is what? General form of the traveling wave is a sine kx minus omega t plus phi naught, right? So if we compare this with this, so phi naught is how much? Amna, what is phi naught? If we compare both these equations, what would be phi naught? Yeah, so this is kx term. This is omega t term. Do you have any phi naught term plus something constant? Do you have that? You don't have that, right? So phi naught would be 0. Phi naught is 0. And then you have this part, right? So A amplitude is 0.005 meters. This is the amplitude. And then we have to calculate wavelength lambda. So lambda, this is first part. Second part, we have to calculate lambda. So this we know. This is K, right? K is 80 and this is radian per meter, right? The SI unit of this K is a radian per minute, right? So K is how much? This is 80 radian per meter, and we know that K is 2 pi by lambda, right? So lambda is 2 pi by K, and K is given 80. So then we can calculate what would be our lambda. Lambda is 2 pi, which is 3.14, right? So 2 into 3.14 divided by 80. So 6.28 divided by 80. So this is how much? We can write this as 8 or 8 sevens, right? So 0.7. And then this is 6, so 8 8 are 64, and 8 5. So this is 0.785, and this 10 is also there, right? So we can write this as 0.0785 meters. So this is the lambda, and then we have to also calculate the period and frequency of the wave, right? So then we have to also calculate period. Period is this one, and frequency we have to calculate. So omega is given. Omega is 3, right? If we compare the equation, so omega is 3 radian per right, so radian per second. Then what would be the time period or this new frequency? So the frequency is we know that this omega is 2 pi by t. So t would be 2 pi by omega. So 2 into 3.14 divided by 3 again. Right, so this is 6.8 divided by 3. And then this is 0 and 9. So this is your time, seconds, and then frequency we can calculate is how much. So frequency is 1 over time. This would be 1 by 2.09, which is nearly 0.5, right? So zero point 0.5 hertz. So these are the answer, and they are also saying that calculate the displacement y of wave at a distance x equal to 30 centimeter and t equal to 20 seconds. Right, so in the fourth part, they have given displacement which is 30 centimeter and time which is how much? Time is 20 seconds. So time is given 20 seconds, right? So then y we already, that is 0.005, kx sine of kx minus omega t, right? And k value, this was given 0.005 sine of 80. X is 3 centimeter, right? So 3 centimeter means that 0.3 minus omega we have given 3 and time is 20. So how much is this thing? 0.005 sine of this is 24, right? And then minus of 60. So how much is this thing? 0.005 sine of minus, how much is this? 36, right? So what is the value of sine minus 36? That they have given here, right? So sine minus 36 is sine 97. So that would be nearly 5 millimeters, right? This is nearly 5 this would be the displacement because we don't know the value of sine of minus 36, right? So these are the questions. Please note it down, and if you have any doubt, please tell. This is one of the doubts, right? Do you have any doubt in this part?
Sir, can you explain the first part?
Oh,
A.
first A. So let's see. Yeah, good, good. Whenever you have doubt, any doubts, let us write the two equations side by side. So y is a sine and kx minus omega t plus 5. So this is the traveling wave, right?
Yes, sir.
And they have given y, which is 0.005 sine and 80x minus 3t. So when you compare besides sine, what is there? A. Besides sine, what is there? So A would be, when we compare these two things, so A would be how much? Right?
0.005.
Yeah, so that is why A is 0.005. Similarly, when we compare Kx, when we compare ATX, right? When we come,
Yes.
so K would be 80, right? K would be
Yes.
80. And then similarly, we can compare this omega, so omega would be 3, and then final. That is how we get, is it clear?
Okay, sir. Yes, sir.
Please note it down, and then we'll quickly understand the other topics. So tomorrow this chapter would be over, and then only a few parts would be remaining. So in next week, all the syllabus, right? And yeah, you please start your revision, otherwise you will get very less time to review, right?
I
I
have started, sir.
good, good, because in the 11th portion, the syllabus are quite big, and there are so many topics to cover, right? This, as compared to the 12th standard, this 11th standard is pretty hard, right?
Sir, how is the 12th standard?
Yeah. Yes.
How is the 12th standard? It is
Yeah.
difficult.
No, no, no. So as compared to the 11th one, right? Because there are so many topics that you saw in 11th standard that was quite different from whatever you have learned in the 10th standard. So there was a big
Yes.
jump in the standard, right?
Yes.
In 10th, whatever you learn, and in 11th, whatever you learn, that is quite different. But when you jump from 11th to 12th, so that differentiation is quite small. So then everything would be not that much different. Yeah, as compared to 11th, the 12th one is the 12th standard, you won't find that much, right?
Okay, sir.
whenever you want me to scroll down these things,
Done, sir.
then, then please.
Done.
Good. So now let us understand. So we understood about the speed of light. So now let us understand speed in different right. So speed of different kinds of right. So first one is the speed or velocity of transverse wave in stretched right thread or string. So why there is a transverse wave? Because whenever we stretch the string, so string moves in crest and trough, right? This is crest and this is trough. So the wave propagate in stretch string is the transverse wave. So what is the velocity of transverse wave in a stretched string? So we know that on string, the force which is acting is tension. Right. So the force which is acting is tension, and uh, and let's say the mass of this stretched string is m. Right. So mass is m. So what would be the velocity of this thing? So it is dependent upon right. Velocity is dependent upon tension, and it is dependent upon mass per unit length. Right. So mass per unit length, what would be that? This is represented by mu, and this is mass by length, right? So if I give you tension and if I give you mu, so can you please, from dimensional analysis, can you figure out the formula? Okay, so let us do that, right? Let us do that from dimensional analysis. We know that this is dependent upon tension, this is dependent upon mass per unit length. That we the velocity of transverse wave in stretched string. So that we know that is dependent upon tension and this right. So now, let us use the dimensional analysis to get the velocity. So what would be the dimension of velocity? What would be that? Yeah. What would be that?
For velocity,
Yeah, dimension of velocity. What would be that? First chapter, right? Dimension of velocity. P is meter per second.
L L1 T minus 1.
Yeah, LT minus 1. LT minus 1. So this would be the dimension of velocity. Dimension of tension, what would be that? Remember, this is force.
M into A.
So M into A. Force is M into A, which is M is kg. Acceleration is meter per second square. So dimension would be what? M L T minus
T
2.
minus 2.
Yes, this is M L T minus 2. Right, good. Now the mu. What would be the dimension of mu? Mu is mass by length. So what would be dimension? Mass by length. Right?
Yes, sir.
So if you want to calculate the formula, so let us write that this is some k constant and e power alpha mu power beta, or let's say AB. That is how you calculate the dimensional form, right? So A and B. And now you have to figure out what is A and you have to figure out what is B, right? So this is what you do in the dimensional analysis. So,
Yes.
so what we will do is that we'll put the dimension of velocity, that is LT minus 1. And this would be, let us say, so K, let us forget about this K. And we'll come to that. So T is how much? T is M L T minus 2 and A. And then we have mu, right? Mu, which is M L minus 1 and B. So if we write this, so what would be this? Right, forget about this K for now, right? Forget about this K. This comes from the experiment, but we'll talk about that later. So this is M A L A and T minus 2A, right? This is again M and B and L and minus B, right? So if we simplify this thing, this is M and A plus B and L A minus B and then T minus 2A minus B. So this is these are the dimensions, right? So if we compare it with this left one, if we compare it with this left one, so this is 1 and this is minus 2. So L power is 1. A plus B is how much? There's no M in here. So A plus B is 0. L is 1. So A minus B is 1. Right. And then also we have got minus 2A minus B. That is minus 2. Right. So this is the other relation. So A plus B is 0, which means that A is minus B. Right. A is minus B. And we know that A minus B is 1. So this from this one, what we'll get? A is minus B and then minus B equals to 1. So we will get minus 2B equals to 1. So B is minus half. Right. B is minus half. So A would be how much? A would be minus of minus half. So A is half. Right. Clear.
Yes, sir.
Then we don't need this one, right? Because we already got A and need that part. So let us put this value in here, right? Let's say this is V is, let's say K and TA, which is and then mu. So K we don't know, that comes from the experiment. T A is half and mu is minus half. So this thing will go down. This would be T half and mu half. And this is K. So this would be how much? K would be of t by mu, right? Because half is root. So this is root t by root mu, so t by mu. And from experiment, this k value is 1, so this is t by mu. So this is the velocity of the transverse wave in the stretched string, right? This is the velocity of the transverse. Similarly, we have a velocity of longitudinal wave, longitudinal wave in solids, because the transverse wave won't propagate in solids. They don't propagate in solids, so we have longitudinal wave in solid, right? As for example, you have the sound waves. So sound wave propagate in solids, right? That is the velocity. So there would be velocity of longitudinal wave in solid. And if we calculate that part, so we'll get this as bulk uh, elasticity and then this density of this solid. So this is right. Okay. And if we are talking about a linear solid, so that would be gamma by this density. These are the things that we have to do, right? This is for bulk solid, and this is for linear solid, right? These are the things that we have to remember. Please note it down, and if you have any question, please ask. Is it clear?
Yes, sir.
Okay, please note it down, and then we'll quickly do a question, and then we'll just then talk about reflection of waves, and after that we'll talk about beams, right? Quickly note it down. Whenever you want me to scroll down the screen, please tell me. Yeah, whenever you want me to scroll down, please tell me.
Done, sir.
Yeah. Okay, so then the yeah, whenever you have noted it down, please just
Done, sir.
yeah. So now let us do some question, and then it will be clear to us, right? Let us quickly do some question, and yeah. So this is the question, right? So a steel wire, right, 0.7 meter long, is this steel wire, right? Length is 0.7 meter, and mass is 5 into 10 to the power minus 3. If the wire is under a tension of if the wire is under a tension of 60 Newton, so tension is 60 Newton, then we have to find out the speed of the traveling wave, right? So speed of the wave. So we know that V is how much? That is root T by mu. So we have to first calculate the mu. Mu is mass per unit length. So mass is 5 into 10 to the power minus 3, and then length is 0.72. So this is mu. So tension is 60, and then this is how much? This is 5 into 10 to the power minus 3, and then 0.72. So how much is this? Right. It, this is 12, right? And then this 12 and 0.72, and then this is 3. How much is this thing? This would be 1 2 into 7 and 20. So how much is this thing? So 12 to the 24, and 84 and 2, 86 and 0. How much is this thing? Right? If we calculate of this thing, so how much would be that? 8640. How many here? 12 into 17, 86, right? Correct. is how much? 8640. So this is 92.95 and meters per second. So this would be that, right? In here they are getting 93, which is closely 92.95, right? This is closely 93 meter per second. So this kind of simple questions you can get, right? So they will give you 2 marks. Please note it down, and then we will talk about the other things, right? So please note it down.
Done, sir.
Done. Okay, so now we have talked about the speeds and also these are all about speed of the traveling. Now the next thing that we have to understand that yes, this part is talk about the beats and standing waves in tomorrow's class. But let us talk about the boundary conditions. What is the boundary condition? So let's say that right, so let's say that some wave is traveling, right? Some wave is traveling. This is the boundary, and these are there are two things. One is reflection of wave from solid or rigid surface, right? And the second one is reflection of wave from, let's say, open surface, which can be fluids, right? These are the two kinds of reflection that they may happen. So let's say that reflection from rigid surface, right? So let's say the wave is traveling and this is the rigid surface. So let's say the wave is coming. This is the wave. This is coming. Let's say this is the incident wave. This is coming, and then it strikes in here. Right. It strikes in here, and if this surface is a rigid surface or closed surface or closed surface, then this will be reflected in this phase. Then it will go like right. It will go like this is out or reflected, right? So one thing that you are seeing, right? one thing that you are seeing is that the propagation. So this is propagating in, let's say, x direction. So the reflected wave will propagate in what direction? So this is the opposite direction. So reflected wave will propagate in minus x direction. Clear? Is it clear?
Sir.
So let's say that for simplicity, let's say that initial wave is A and sine kx, or let us write as omega t minus kx, right? So omega t minus kx, right? So this is in the x direction. This propagation is in the direction of x. Now the reflected wave, so it will have also a phase shift, right? There would be a difference in the phase, right? So when it is going this way, so it will go in this way, right? This would be the reflected wave. So phase would be different. So y reflected, that would be a sine. And we know that propagation is now in minus x direction. So that would be kx. And there would be a phase difference of 180 degrees, right? This is totally in the opposite direction. So the phase difference is this. So we know that sine of 180 plus theta, that is minus sine theta, right? So using this property, this is pi, so we can write minus a sine the omega t plus k. So this will happen. This way, this is showing that direction is changing, and this is showing that phase is changing. Right. So this was the original incident waves. This was incident wave, and this is the reflected, right? So this is from the rigid surface, and we know that in rigid surface, phi would be pi, right? So this we have that phase difference is pi. In rigid or closed surface. But let's say that wave is falling on a fluid, so from open surface. From open surface, what would be that? From open surface, phase difference is zero, right? There is no phase difference. So then we have this is the the incident wave, right? So if it strikes this one, so then the outgoing wave would be just in the same direction, right? So in the opposite direction, but this would be against, this would be the reflected wave. So this would be in the same phase would be zero, phase difference would be zero, but only the direction will change, right? This is incident wave, and this is the reflected. So if yi is a sine omega t minus kx, so y reflected, that would be simply a sine, and only the propagation is changing. So this would be simply plus kx, and the phase difference would be zero. This would be simply a sine omega t plus k. This is the reflected wave in the open surface, right? This is the reflected wave in open surface. So is it clear to you? Are these reflections clear?
Yes, sir.
Then please yes, so this should be. Whenever you want me to scroll down, please.
Done, sir.
Then, then please down.
Done, sir.
Done. Okay, so now let us understand. This is a very crucial part, right? So you understood that whenever the propagation is in the negative x direction, so that is how we write the displacement, right, of the wave. This is very important. And whenever the propagation is in x direction, positive x direction, so that is how we write the propagation, right? Okay, so now let us talk about this is very important, right? Superposition of right. So when or so it states that the overall displacement of all the individual traveling waves be linear or algebraic, be algebraic sum of individual waves. What does it say? That let's say you have y1 displacement, y2, y3, and so on. Let's say yn. So the overall displacement, the total displacement would be just y1 plus y2 plus y3 plus y. This is the superposition, right? They will add just algebraic. So this is the superposition of waves. And this part we will use in times, right? So one we would use in beats. So beats is how do you relate beats? So you have already heard about these beats, right? So
Yes, sir.
so beats are related with what kind of wave, or it is related with what? So beats is related with the sound, right? So this is related with sound waves, right? And then we have this standing. We have a traveling wave, but on what condition? This would be a standing wave. So standing wave has a peculiar property, and both these things comes from this superposition, right? So in tomorrow's class, we'll talk about these two independently. But to do that, we have to just remember this superposition, right? So quickly note it down, and we will stop at here. And in the next class, we'll talk about the last topic, which is beats and standing. Quickly note it down. Yeah, whenever you have routed, please tell.
Done, sir.
Okay, so we'll stop at here and